tutorial we'll learn to create a recursive function, a function that calls itself. So recursion is a process of defining something in terms of itself, a physical world. Example would be to place two parallel mirrors facing each other, and any object in between them would be reflected recursively, right? So Python recursive function is, we know that, a function that can call other functions. So it is possible for the function to call itself, as mentioned above, right? So this type of construct or functions are termed as recursive functions. So recursion is a programming technique where a function calls itself to solve problem by breaking it down into a smaller subproblems. So the function of this recursive function is that to any kind of big problems, it will break down that kind of problem into smaller subproblems and calculate, and then it works accordingly. So in Python you can write recursive functions that call themselves until a base case is reached, so at which point the recursion stops, right? So here is an example of a recursive function in Python that calculates the factorial of a number. So let me talk in this example here. Def factorial, and inside parentheses n here. So if we given a statement here, this is very important, okay? So if n is equal to 0, if the value of n is equal to 0, right, it's comparison, it's doing comparison because double equal sign here, you can see operator, right? So if n is equal to 0, written on 1, else written n multiplication factorial n minus 1. So this is how we can use recursive function here. So it will written as we assign here, right? Factorial number defined as n here, that means argument here, and if this n is 0, written 1, otherwise or else written n multiplication factorial number, this factorial number here, because we already given there n minus 1, because n already given here, n minus 1. So that this is how it works. So this function actually takes a number n as an input here and calculates the factorial of n using recursion here, right? So the base case for this recursion is when n is 0. In this case the function returns 1, and otherwise it multiplies n by the result of calling itself factorial number or the argument n minus 1. So this recursive call continues until the base is reached. Base is here, the numbers base, right? So this is how it works. Recursive function works in Python. So to call the factorial function to calculate the factorial of a number, you simply pass the number as an argument here. For your better understanding, we can do this one like 10. Okay, for example, I have just result is equal to factorial 10 here because we already created factorial function here, and I would like to print result here. Let's run. So this is the number. Okay, this is too much big number, so let's create 4. Okay, factorial number of 4 is equal to 24, because how it works is like, later I'll give in details here. So in this example you can see the factorial number called, here is 5. So so in this example the factorial function is called with argument 5, right? Argument 5 here, you can see factorial number 5, factorial number of 5, that means. So with which calculates the factorial of 5 using recursion and returns the result, which is then stored in a variable result, because we have given the variable name result here and printed to the console. That means 120 here. Recursion can be a powerful technique for solving certain types of problem, but it is important to use judiciously and make sure that your recursive function have a well-defined base case to prevent infinitive recursions. So it is also very helpful to make your code very short. That means short and clear understanding. So it will be very good to use recursive function in Python. So for your better understanding here, I have just created an example of recursive function here. Def factorial of number of x. Number x, this is a recursive function to find the factorial of an integer. That means here x. If x is equal to 1, return 1. I have given a statement here, recursive function statement, else return x multiplies by factorial number x minus 1. For example, if we put here 4, what will happen? So number here given here 4, and print the factorial number of number is factorial number. So let's run it. The factorial number of 4 is 24, right? So how it came 24? Why 24? So that is very important to understand. So in the below here, I have given very details, description here for your better understanding. In the above example, factorial function is a recursive function as it calls itself, right? As it calls itself. So when we call this function with a positive integer, it will recursive call itself by decreasing the numbers, because we have given here decreasing the number x minus 1. If the number is x here, the factorial number will be calculated and returned to the console and printed out here is x multiplies by factorial number x minus 1. If you put here 5, that means 5 minus 1, 4 again and 4 minus 1, 3 again and 3 minus 1, something like that. So until 1, because we have given 1 here, right? If the x is 1, not 0, we have given 1 here. If you put 0 here, so the number will be iteration will be until 0. So this is how we have to understand here. So each function multiplies the number with the factorial of the number below and until it is equal to 1, because this statement is very important to understand. If function, right? If statement, sorry. So factorial number 4 here, how it worked above is I have given details here. Factorial number of 4, that means first column with 4, number 4, that is, this is an integer. So in the second step, 4 times 4 multiplies by n minus 1, that means 3, factorial number 3, this is second step, right? So then again 4 multiplied by the number again will be 3 here, so the 4 multiplied by 3 and multiplication multiplies by factorial number 3 minus 1, right? So 4 times 3 times 2 times multiplications, that means 2 minus 1 is equal to 1. So 4 times 3 times 2 times 1, that means 24, right? So this is how decreasing here, decreasing the the calculations here slowly. That means the structure of calculations becoming sized, small size. So 4 times 3 times 2, 1 is gone because 2 times 1 is equal to 2, right? 4 times 3 times 2 is equal to 6, so 4 times 6 is equal to 25. This is how it works. This is how it works here, so that the result came out 24. So here we have to understand that our recursion ends when the number reduces 1, reducing 1, right? Because we have given here, you understand, you have to understand that we have given the number x, so the factorial number will be multiplied by x minus 1. That means if we put here 4, 3 minus 1 into 4, that means, and again here 3 times 3 minus 1, 4 times 4 minus 1, something like that. So this is how it works, and every recursive function must have a base condition that it stops the recursion, or else the function calls itself infinitely, right? The Python interpreter limits the depth of recursion to help avoid infinite recursion resulting to stack overflows. By default, the maximum depth of recursion is 1000. So if I put number 2000, what will happen? Let's see. It is X here. It is the maximum number, maximum depth of recursion here. If we put like 2000, something like that, how it works. The factorial of 2000 is like this, right? This is how. But the limitation depth of recursion, the iteration, will be 1000 times, not more than that. That is the maximum limit, right? If the limit is crossed, the result of recursion error. Let's look at one such condition. So such condition is here, even I have given here. So def recursor function again, and recursion print out the code. The code you provided is an example is, see, maximum recursion depth existed. So recursion 1000 print recursion, invalid syntax, sorry. So this is how it throws error. So the code you provided, code I provided here, the example of infinitive recursion, which means the function recursor calls itself indefinitely, right here. So it does not have a base to stop the recursion. We didn't have defined that recursion. So, but when you run this, the program will continue to run indefinitely, right? So until it reaches the maximum recursion depth allowed by Python, so which the point will rise recursion error. So it is important to note that infinite recursion is a common mistake when writing recursive functions, and can lead to serious performance issues or crashes if not handled properly. So to avoid infinite recursion, you need to make sure that your recursive function has a base that stops the recursion when certain conditions are made. Right. So this is how it works. So what is the advantage? What are the advantages of recursion function? So recursive function make the code look clean and elegant. A complex task can be broken down into simpler sub-problems using recursion, and sequence generation is easier with recursion than using some nested iterations. This is how we iterate here, right? This is an example of iteration here, that to understand here is better than. And then sequence generation is easier to recursion using some nested iteration. Okay, so disadvantages of recursion. Sometimes the logic behind recursion is hard to follow through. Recursive calls are expensive, inefficient, as they take up a lot of memory and time, because for example you can see here a lot of memory, it uses a lot of memory and time, so that it says like that. So and the recursive functions are hard to debug. If there is any problem to debug, it will take time, and it is very hard as well. So this is how we have to understand these advantages and disadvantages of recursive function. So how can we use lambda function as a key to sort a list? There are some benefits of using recursive function as a key to sort a list here. So for example, for your understanding, I created a variable name called names is equal to, I created a list, Ram, Hari, Govind and Manoj. So I printed out names. That means let's run it. Okay, it printed out the names that we have listed here. This is a list of names variable. So again, if we sort name here, that means also, okay, this is actually no need, this one and this one is like same, but this is more organized way to write the code. So now here names.sort, I'm just going to sort the list using lambda function. Okay, so names.sort here, so names is a variable here, and then that sort function I created a sort function here. So inside sort function I define that key is a lambda as a lambda function, and argument is x, and the length of this x, so print names, that means it will print it out the same result as given above. So this is how only one line of code is enough to print it out the list here, right? This is how we can use lambda function as a key here to sort a list, right? So another example of lambda function is here def double n, for example here. So return n multiplies by 2, that means print double is a variable we assigned given here, that means inside the number is 5 here, we given number 5 to return the value of n times by 10, that means 10, right? So this is resulted here like 10, I mean 10, number 10, right? This is how it calculates. So here is how we can use lambda function to get the same result as above. So double, for example, this is not, we are not using a lambda function here, but to this example we are using lambda function here in one line. So it is very simple and very short and very clean code, right? So double is equal to, in the same example here, in the same code here, I mean we rewrite the code using lambda function, that means double is a variable here we define, so is equal to, we created lambda function here, and n is number, that means argument, and n multiplies by 2, that means a statement we give to calculate, right? N multiplies by 2, that means if you printed out double 5, that means the result will come out 10. If we put 10 here, the result will be 20. So this is how it works. So the double is a variable here, we should understand. Equal is operator sign. Lambda is a function that has no name, that's why it is also called anonymous. N is a parameter, also argument we can say, and the n multiplies by 2 is a return value of the function of lambda function, or syntax, also we can call it syntax. And this is print statement, and we give to print out the statement variable defined here double as given here, and 10 is a number that we given Python to print out. So this is how it calculated, right? So lambda function with multiple arguments here, we can create a lambda function to return the largest number among the multiple numbers as well. So this is also interesting, and you can see here that larger is the name of variable is equal to lambda a b. These are the argument, multiple arguments we can call, and a is one of the argument we given here, and we have also defined we have given the if statement here. If a is greater than b, print a, otherwise or else print b. That means, so in a single line of code we can understand that lambda function is very useful to print out even the to find out the largest number among two numbers or multiple numbers. So to print out the to print out the numbers largest number here, I have created a print statement here, and inside the print inside variable of larger 10, 15, there are two values I have given here. So which number is bigger among these numbers, 10 and 15? Of course 15, right? So it will print it out, it will be printed out 15. So you can see here, I run already, and you can see here. So in the above example, larger is a variable, lambda is a function, a and b are the two numbers or arguments. A greater than b is a return statement that we assign to Python to do that work, if else statement, and last line refers that print statement, right? This is how it works. So that's all in this video. Thank you very much for your time. Thank you for watching. Please do not forget to subscribe my channel if you would like to get updates, new updates about Python and other programming languages. Thank you very much once again. See you in the next videos.